A gymnast is practicing giants on a high bar. This is a move in which his body goes in a full circle around the bar while the gymnast is holding the bar with the arms extended. So it's kind of like your arms are straight, your whole body's straight, and you're flipping around the bar. If a gymnast does a series of giants in a row at a constant pace, the distance his feet are above the ground at any given time t can be modeled by this equation. What is the period of this function? So we're going to find period using the period formula. So this is A, B, and C in the formula. A cosine bx plus c, or bt plus c. Period is 2 pi over b, so that's going to give me 2 pi over 8 pi over 7. So that's 2 pi over 1 times 7 over 8 pi. Cancel the pi's, cancel here. So that gives me 7/4, which is, in this case, I think for the next one, 1.75 is actually going to be more useful for me to describe it. So it says, based on your answer to A and the context of the problem, determine what unit of time is being used for t. So do we think it takes 1.75 seconds for him to complete a cycle, 1.75 minutes, or 1.75 hours? Seconds is really the best choice. If you've ever watched gymnastics, it does not take hours for somebody to flip around the bar, or minutes. Seconds makes the most time. Right, so I'm just going to write it's a short amount of time to flip around the bar. It does not ask for an explanation here. I'm just writing one more to show you, right, for notes, okay, but that is the best choice. What is the midline? So the midline is 109. What are the minimum and maximum values of the function? So the minimum, and this is just and actually we should label this D, okay, because the C value would be a phase shift. We don't have one. So to find the min and max, we take the midline and we subtract the absolute value of A. We'll find the midline, we'll find the min first because that's what it says. So D minus the absolute value of A. So that's going to be 109 minus the absolute value of negative 85. So basically I'm doing minus 85. This becomes positive because of the absolute value. So that is 24. And then the maximum is going to be D plus the absolute value of A. So I'm going to write that down here. That's going to be 109 plus 85, which is 194. It says, based on your answers to parts B and C in the context of the problem, determine what unit of distance is being used for S of t, centimeters, inches, or feet. So the question is the midline 109 centimeters, 109 inches, or 109 feet? So if it was centimeters, the midline, which if we think about it, if his feet are going above and below the bar, the midline is the bar. If it was 109 centimeters, that means the bar is about 3 feet high, which is not going to work for most adult gymnasts. If it was, and really, if you have your arms straight out, it's not going to work out for anyone really who's over the age of 1.5. Inches sounds good. Feet, having the bar 109 feet in the air is definitely not the way gymnastics works. So we're going to say inches here. Okay. And you could write different answers. I think really thinking about, it's the only one that makes sense for 109 to be the height of the bar. So our next one has to do with our Pythagorean identity. We're going to use the picture of the unit circle to the right to prove the Pythagorean identity, and we actually already have it labeled. So when we were doing this in class, our step 1 was to draw the picture. That's already done for us. Our step 2 was to write down the Pythagorean theorem from this triangle. So that's x squared plus y squared equals 1. Our step 3 is to notice from this picture that the sine of theta equals y over 1, which is y. Okay, so that comes from opposite over hypotenuse. And the cosine of theta is x over 1, which is x. So therefore, in place of x, right, I can plug cosine theta, and in place of y, I can plug sine theta. Now this wants us to write the sine theta first, so that's really just commutative property. So then we would just write sine, and we write it with the squared here, sine squared theta plus cosine squared theta equals 1. And as I said, we kind of switched the order from what we had here, but that's the typical way to write it. The next one, it says, on a summer day in Cape Cod, the depth of the water at a dock was 4 feet at low tide. At high tide, 5 hours later, the height of the water at the dock rose to 14 feet. Write a trigonometric function to model the height of the water at the dock x hours after the day began. So 12 a.m. is the 12th midnight. It's starting at 4. At 5 a.m., so 5 hours later, it's going to go up to 14. So this is a 4, that's a 14, and then so that means at 10, it's going to come back to its starting spot. So first off, we see that this is a negative cosine graph. They don't tell me to use f of x or anything like that, so I'm just going to use a y equals. So we need negative cosine. We're going to need something with the x, and we need a number that goes here. So these are my 3 spots to fill in. I usually like to start with a midline. So the number that's directly between 4 and 14, we could add them and divide by 2 if we think that's tricky to figure out, is 9. So that goes plus 9 here. That's our midline. From the 9, we go up 5 to get to the maximum. So I'm going to put a 5 here. That's the amplitude. And then the period here is 10, right? 10 to complete the cycle. So we do 2 pi over 10 to get the b value. So that's pi over 5. And that's what goes right here. On the axes below, graph 2 cycles of a cosine function with an amplitude of 2, a period of pi, and a midline of y equals 3 that passes through the point 0, 5. So I'm going to draw in that midline first. Here's my y equals 3. They want a cosine curve, so I'm going to start up at the top. They tell me it passes through 0, 5. So we're starting right here. Now, actually, we could have done, this really indicates to me that I know I'm starting at the maximum, so it's positive cosine. We do already know the amplitude is 2, so that does make sense. Now, I need a period of pi, so we need 2 cycles. So I have a couple options. I'm going to go forward. So I'm going to put pi here. That should be 1 cycle, and 2 pi for another cycle. If it starts up here, that means it's going to go down to 1 and come back up to where it started from. So this is 1 cycle. I'm going to do my best to cross through kind of here. I didn't do a great job on this side. And then we'll just graph another cycle. So it's going to come down, be on the midline in the middle, and come back up. So that's 2 cycles. We don't need an equation here. We're just using the information that's in the problem.